Okay, so the question says a charged particle with charge Q moving with velocity v enters a region perpendicular to a uniform magnetic field B and follows a circular path of radius r. Show that the kinetic energy of the particle can be expressed as kinetic energy being equal to charge squared, radius squared, and magnetic field squared, being divided by 2m, which is mass, where m is mass of the particle. So when you are trying to show here, you need to have about 3 equations in your head. Number one, you must have the equation about the kinetic energy, and then you must have also the equation for force. Okay, and this force, we have to deal with the magnetic force, and then we will have also to have the equation for centripetal force as well. So now we know that kinetic energy is given as half mass times v squared. All right, so this is, we can say this is our equation 1. Kinetic energy is equal to half mass times v squared. So we're going to say this mass is the mass of the particle, and the v is the velocity of the particle. Now, the magnetic force, what we have force being equal to now here we have been taught to say this particle is entering a region perpendicular to the magnetic field. So if perpendicular means that the angle between the magnetic field and the velocity there is what? It's 90 degrees. It's perpendicular, so it's 90 degrees. So theta here is 90 degrees. Therefore, sine 90 equal to 1. So this equation is going to be QVB. So you have that one. Now, when it enters the what's this? The region, it begins, or it follows a circular path. So there'll be a force that is going to be exerted towards the center of that path of radius r. So we have something like this, a path, and then this path has got a radius r. So now this particle is moving in that circular path. Then the force that is going to be exerted towards the center is what we call centripetal force. So centripetal force is given as mv squared over r. That is centripetal force. So for this to continue moving, it means this magnetic force and the centripetal force must be equal. So we are saying we're going to have this being equal to that. So that we have mv squared over r equal to charge VB. So we're going to have at end V and V will cancel like that. And then this one, we're going to have mv over r equal to qb, like that. So now we can cross multiply and then make v the subject of this formula. So which is going to be v equal to qrb over m. Right? So this will be our equation 4. So now we found the velocity at which this particle will be moving in that circular path. And this will be the velocity. So now we take equation 4 into equation 1. So we're going to have, we erase here. All right, so we're going to have kinetic energy being equal to half m. V, we have found QRB over m squared. So we've substituted where there is B with V, we substituted with that. So this is going to be half m, and then we have this is squared. So meaning everything inside here, we're going to have Q squared, R squared, B squared over M squared.
Yep.
So we have M here and 1M will go. So that we're going to have kinetic energy equal to Q squared, R squared, B squared over 2M. Hence, shown. So this is what you're supposed to do for you to get that one. So that is how you derive that equation.